So we're going to get underway tonight. We've got quite a lot of slides to get through, so we'll get underway. And we're going to start the first slide with a poll. And this is just a bit of a reminder of what happened last time. And there is the poll, and I'll just go and sort that and put it on the chat.
There's no poll appearing, Simon. There's just
and we'll push send, and there, that's done now for those, the chat's there. And now we'll go back to my polls. This makes me dance around a bit. Okay, so let me just go and see the results. Just a bit further down, view results. So we've got quite a lot who believe C is the right answer, Ray, 88%. There's a few that think B is the right answer.
Well, apologies for this is a bit of a revision poll from last session, and apologies for sort of repeating if you've read all the pre-course material and what we covered last week. But some of these things are so important, so I thought just starting off tonight with a bit of a check on what you picked up from last week. What happens to pressure and temperature with height? The answer is pressure decreases and temperature decreases with height, at least in the parts of the atmosphere that we care about, the troposphere. So the answer is I think B is the answer is C is the correct answer.
All right, we'll close that poll, and we've now got another poll which Ray has sent you, so I'm going to launch that one. And that's popped up. So we'll just go and get that in the chat.
And this is an incredibly important aspect of interpreting weather maps. So the way the wind blows around low or high pressure systems. So in this case, it's a low pressure system in the southern hemisphere. How does the wind blow? Well,
okay, well, we've got, everybody likes A, Ray, I can tell you. 13 responses thus far.
What was that? So most people like B,
A.
which some people like A, unfortunately.
Oh, there's quite a few who like A.
Yeah, unfortunately. So the answer is in the southern hemisphere, the wind blows clockwise around a low pressure system and in towards the center of the low. So the correct answer to that was B, towards the center of the low.
Yeah, sorry, Ray, I was looking at the wrong one. I was looking at last week's. Most people, 92% have picked B.
Picked B, about a couple have picked A. So again, in the southern hemisphere, wind blows around clockwise around a low pressure system and in towards the center of the low. Okay.
And in the chat, they all went for B.
Good.
So we'll just close that poll, and I've got one more poll which I'm now going to launch. And so I'll launch that one. And let me just go and put that in the chat for those who need that.
So the answer is, the question is, does air rise or fall in a high pressure system? Does it rise or fall?
It's not a complicated one, that one, Ray.
No, but
only two choices.
It seems to be challenging some of the answers, though.
Let's go and have a look what they say. View results. Oh, yes. Got 56 for one and 46 for the other, right? That wasn't the outcome we were looking for.
We didn't get that one right. So the answer, okay, so in a high pressure system, the air descends. It's in a low pressure system where the air rises. So this is very important to understanding a lot of aspects of weather in terms of the cloud formation, in terms of precipitation, in terms of some of the wind properties. So in a high pressure system, wind is falling. In a low pressure system, it rises. Pretty important. Okay. So
Over to you, right?
Let's move on. Okay. Okay. So, okay. Following on, we talked last week. We talked about the weather maps that the Weather Bureau produces, and so an important aspect of that is how do these weather systems move? And the answer is in our latitudes, the weather generally moves from west to east. So you can see here a couple of weather maps. This one early on, and now it's a day. What's it? A day a bit later. This is 10 a.m., 10 p.m., where the low pressure system has moved to the west. So generally, well, the weather moves from west to east, and it's driven by the global wind circulations we talked about last time, and also the Coriolis force. And so the weather moves across from the west coast to the east coast in a few days, and that's the general trend. However, every now and then you can get high pressure systems that tend to form a little bit south of the continent, and they can actually sit there and be very stationary, and they can block the movement of the pressure systems across the continent. So you get these blocking highs that happen from time to time, and they can cause the weather system to stall somewhat. But generally, the weather moves west to east over the few days, and you can see that as if you watch the maps from the Bureau. The other thing that's important is that the weather maps change from summer to winter. So as a general comment, in summer, the high pressure belt is towards the south of the continent, whereas in winter, the high pressure systems tend to be more northerly. And in some of the high pressure systems being south, the effect is that of the westerly winds and the cold fronts have more impact on us. But so this trend between seasons is very important to understanding the wind patterns from winter to summer. Okay, let's just have a look a little bit at if you think of a high pressure system here, what would the wind if you walked across this high pressure system, what would happen to the pressure? So, okay, I see there was a typo in that. Sorry if there's a typo on the last slide. I'll have a look at that. Okay, so back to this slide here. How does the wind pressure, the atmospheric pressure change as you go across a high pressure system? Obviously, if you're going across from west to east here, it will start off gradually increasing, reach a high, and then gradually fall off. And conversely, in a low pressure system, if you go across here, it will start off higher and go lower towards and then rise again on the other side. In the center of these systems, of course, the wind would be very low. Because the wind pressure, the wind speed is determined by the spacing of these isobars, as we talked about last time. Closer spaced isobars give you stronger winds, and broader ones give you lower winds. In the center of these high or low pressure systems, of course, the wind there's no pressure gradient, so the wind is very low. But of course, and the broader these pressure systems are, the more widely spaced they are over the country, the lighter the winds will be. The other, so we talked that's the horizontal system situation. What about vertically? Well, we've talked last time about how the surface, the wind blowing across the surface of the sea or the land, slows the wind right down because of friction. But as you go up in height, of course, there's quite an increase in speed. So here's an example of just a typical graph of how the wind speed, it might be only 2 or 3 knots at the sea level, but as you go up, it can get quite a bit higher. As you go up to 100 meters, it can be quite a bit stronger. So an important thing to understand is that the Bureau, when they quote wind speeds, they're quoting them at 10 meters, and they're quoting them over an average of 10-minute period. So they're ignoring the gusts, they're smoothing them out, they're giving you an average wind speed at a 10-meter height and over a 10-meter average. But of course, this wind gradient with height has obvious impacts on sail trim, and particularly true in light winds, because the friction, there's with friction in light winds, the wind speed increases with height is more dramatic. So that has a significant impact on sail twist and all that sort of thing. But so it's important to understand both how the wind changes horizontally and, in fact, in this case, vertically. Okay, so just to remind you, the Bureau, when they quote wind speeds, are over a 10-minute interval and a 10-meter height. And keep in mind that the gusts, as they'll tell you, can be 40% higher. And 40% higher doesn't sound like that much, but that means doubling the force on the yacht. So it's a significant difference. So the gusts have to be factored in very much into how you approach your sailing. The other thing is that in Australia, the Bureau has the way it measures wind speed, or is that we talk about strong wind warnings, which are 26 to 33 knots. And keep in mind that means the gusts can be 36 to 45 knots, and gale force is 34 to 47, and storm force 48 to 63. So this is the system that's used universally in Australia. It's not the same that's used all around the world. An older, more traditional way of measuring wind speed is what's called the Beaufort wind scale, which goes back to an old Royal Navy admiral, and it really came about way back when people didn't have instruments measuring wind speed, and so they tend to base their observations of the wind speed based on what things were doing, the condition of the sea, spray coming off, the tops of waves being blown off, and these sorts of things. So it was a more practical way of measuring wind speeds. It's internationally recognized. It's not one we use here in Australia. The Bureau uses its storm and gale, rather strong wind and gale and storm wind warnings. But the Beaufort scale is something that's used internationally. I've done a lot of sailing in Europe and around England, and certainly when the weather warnings come on, they will quote force 5, force 4 winds all the time. So it's a very international scale, but it's one that we don't use here. We use the BOM scale.
Can you go back to that the BOM scale, Ray,
sure.
and just to feel the gusts there? Because I don't think you mentioned those, because that's quite strong, the gusts in strong wind warning, for example.
Yeah. So if you
getting
see
45 knots was scary.
Yeah. So if you see a strong wind warning, which is 26 to 33 knots, the gusts can be as high as 45 knots, and that's significant. So as I said before, those 40% increases in speed means the force on the yacht can be twice what is the average. So it's significant. So you have to factor in terms of your sail trim and whatever canvassing you've got up, just what those gusts could be, because the gusts can be significant and the forces will be significant. Okay,
Thanks,
so
Ray.
let's. Okay, so just moving on with some of the sort of other technical aspects of weather. So I want to talk a little bit about sea breeze here, which is an effect you see commonly on the bay here in summer and more generally. What happens is during the day, of course, the land tends to heat up faster than I've got a typo here. The land heats faster up than the sea, so that should read sea here. So what happens is, as the sun comes up in the morning, the land tends to warm faster than the sea, and as that happens, the warmer land causes the air to rise, and that air rises and then the cooler breeze from the sea, which is not heating up as fast, comes in to fill that void. So the warm air is rising over the sea, and the cooler breeze over the land, and the cooler breeze from the sea is moving in to fill that void, and that gives us the sea breeze effect. As this air rises, you can often get cloud forming over the coast, so that can be an early telltale sign that you're getting some sea breeze. It usually runs out by later in the afternoon, and of course, if that sea breeze is in the same direction as the gradient wind, that is the prevailing wind from the pressure system, then of course you can get much stronger winds, and the converse can happen. So these sea breezes can be very important in certainly in bay sailing, but even in coastal sailing you can get these afternoon sea breezes that can have a significant effect on your sailing. Likewise, at night, the reverse happens. So the land will cool faster than the sea. The sea has a moderating effect on the land. So the land will cool faster, and so the air will warm over the sea and tend to flow into the land, and the cooler breeze from the land will run out. And so you get this land breeze that can happen sometimes, and it can be so it will start in close and gradually move out further to sea. If there's cloud over the land, that will affect the rate at which the land cools, and so the effect can be weaker. But land breezes and sea breezes can be an important part of a sailing strategy. Okay. The other thing I was going to like to mention is what are called katabatic winds, and these are winds that can occur when you've got wind on and in high altitude areas where the air cools at night particularly, and because as it cools it becomes more dense, and then the gravity of that will cause it to roll down the hills out onto the coast. And it can be particularly strong where the wind is coming down valleys like glacial valleys and what have you, and you can get some very significant effects from these katabatic winds. Earlier this year, I happened to be in Antarctica, and one day we'd gone ashore to a little settlement called on South Georgia called Grytviken, which is it's the site of a British research station, but also famous because it's happened to be the burial place of Ernest Shackleton, the very famous polar explorer. And we just got ashore there in our little rubber Zodiacs, and after about 15-20 minutes, an enormous wind came down from off the land, 50 knots. And what had happened is that you've got this very cold air up above the mountains rolling down this glacial valley, and within about 20 minutes we had 50 knots of wind. The sea was a washing machine, and we were stuck there for like 3 hours until this katabatic wind had moderated. So it can be in places, well, Antarctica is an extreme case because you've got very high altitude coastal features, very cold air, and it can roll down these glacial valleys. But it can also happen in other places. I mean, you can get this on the west coast of Tasmania, where you've got some mountainous coast, and at night when the air cools, it can roll down the valleys. So it can be very important in terms of, well, from a sailing race perspective, but also in this particular case in Antarctica, it was actually quite dangerous. We had to sit out for about 3 or 4 hours until the wind moderated, so we could get back on the mothership. So katabatic winds in these situations can be very quite significant. Okay, let me
push play again. Push advance, it'll play.
Oh, yeah, okay. Here's an example of in Antarctica. I can tell you, during that time in Antarctica, particularly around South Georgia, it was always very unpredictable as what we could do, because these katabatic winds could roll off the hills down the glacial valleys somewhat unpredictably, and so our ability to go ashore and see things was very dependent on these katabatic winds. Okay, little question here. At what height and over what time does the bomb measure wind strength?
The poll's up there now, if you can see it in the chat, but I will put it in the chat for people who can't see the poll because their pop-ups are blocked. There's the poll in the chat. And get the polls and go and have a look what's happening.
Okay, good.
Few results.
Okay.
86% so far.
All good.
We've got 14 responses, so we might give them a bit of chance to see if somebody else can write. And if you can't see the poll, just put your answer in the chat. There were 14. Any advance on 40? There's 40 of us here. We should be able to get a few more responses than that. Okay. We've got C is pretty popular. We've got Janet. All right, Ray, you can talk about the answer.
All right, so the answer is, as we mentioned, the Bureau measures, when they quote wind speeds, they are averaging over 10 minutes and a 10-meter height. So something to keep in mind. And remember again, the gust can be 40% more than that average over the 10 meters. So it's ignoring the gusts. Although, as Simon showed last time on the bomb app, one of the nice things is it is showing those gusts, so it can give you an idea of what's going on beyond the averages. Okay.
Next
all right.
Poll, is it?
Next question is, what are the range of wind speeds for a strong wind warning?
Oh, getting quite a few messages over the chat.
Yeah, good.
And I'll just go and have a look at the poll. View results.
Yeah, all good.
16 say that everybody's getting it right by the look of things, Ray.
I think that message that message has got through. I think we can tick that one off. Okay. Yeah. Let's move on. Clouds. Let's talk a little bit about clouds, and we could spend a whole session on clouds, so we don't have that time. But why do we want to study clouds? And the answer is because it gives us an indication of the vertical motion of the wind. We've talked about the horizontal movement of wind through the weather maps, but the vertical motion is equally important to understand what the current wind is doing, and in fact what the trends will be, because what's happening in the upper atmosphere eventually ultimately impacts what's happening in the at ground at sea level, where we care about the wind. So in being able to understand the vertical motion is important, and clouds give us a lot of clues about that. Okay, so what causes these clouds? And the answer is it depends on how the air moves through the atmosphere. So if a parcel of air has a higher temperature than its surrounding, then it will go up. If a parcel of air has a lower temperature than its surrounding, it will fall, and that's considered a stable atmosphere. Of course, if the parcel is rising, it's unstable. It's going up into the atmosphere, and it will produce clouds. And if a parcel of air has the same temperature as its surrounding, it's neutral. It will sit about. Okay, so an extreme example, perhaps, of how this happens is what's called orographic lifting, and this is where you've got moist air coming from the air blowing over the sea, coming into a coastal mountain range where that's an obstruction, so it has to rise up over the hills. As it does that, it cools, and any water vapor that happens to be in that air will condense and become water droplets, and it will produce rain on that windward side of the hills. The wind will continue over the mountain, and on the other side, it's lost all its moisture and it's quite dry. And it was very interesting. A couple of months ago, I spent a few weeks in New Zealand, particularly in the South Island, and it was interesting to compare the glacial valleys in New Zealand on the west coast compared to Antarctica. In Antarctica, it's very cold, very barren, very icy, quite mountainous in some parts, particularly in places like South Georgia. And in terms of vegetation, you're lucky to see grasses that grow up to 1 meter high. Compare that to the west coast of New Zealand, like in the Franz Glacier or Fox Glacier, or further down towards Milford Sound. And there, the westward side of the island is rainforest. In fact, in Milford Sound, the annual rainfall there is 7 to 9 meters. I say that again, 7 to 9 meters. It's incredible. It's twice what you get in the Amazon rainforest. So when you're walking around the west coast of New Zealand, even in glacial valleys, it's rainforest stuff. You're walking amongst 60-meter high trees. It's so verdant. It's so the vegetation is so lush, and it's all because of this. The wind coming from the west, picking up moisture from the Tasman Sea, rising up over the mountains on the west coast of the south coast of New Zealand, dropping all its rain on the west coast, and producing very lush vegetation, even in glacial conditions. And then on the other side, as you go into the inner parts of the South Island, it's much drier. So orographic lifting is a very important mechanism for lifting of wind and producing rainfall and of course clouds over the windward side of that flow. As far as clouds are concerned, they're named based on, first of all, their height. Are they low, middle, and height? Their appearance. Are they curly? Are they layered? Are they lumpy? And then finally, what sort of weather conditions do they bring? And of course, we know about nimbus clouds that produce rain. So the criteria that determine clouds are their height, low, medium, and high. Are they the shape of them? Are they layered clouds, or are they lumpy clouds? And then are they rain-bearing clouds? We could spend a lot of time talking about all of these, but because it's a science in itself. But certainly, being able to interpret or read the signs from these clouds is an important indicator of the weather that is likely to come along.
Ray, we just got a question from somebody who says, could you explain the large cigar shaped cloud mass in the clear sky prior to Meltemi, which is the strong wind and hot conditions in Greece?
Can you explain the large cigar-shaped cloud mass in the clear
cigar-shaped cloud? Yeah.
I don't know. I've sailed. I haven't sailed in Greece. I've sailed in Turkey quite a bit. I don't know the Meltemi winds enough. Can you explain the large? I don't know the answer to that.
You'll come back next time with that, right? Won't you?
Okay, I'll look at it. Okay. Yeah. The orographic lifting, is this what you see in the Otways? You can see it. Yes, it's not limited to, I mean, the Antarctic is an extreme case. And then, of course, I mentioned the west coast of Tasmania. But you can also see it in inland mountain ranges, of course. Wherever you've got the opportunity for winds aloft to cool down significantly at night and then come down then with gravity pulling them down the valley. So yes, you could, I don't know the Otway specifically, but you're certainly not limited to these extreme cases. You can certainly see it in places like the lofty ranges in South Australia. I could easily imagine it being the case in the Otways as well. Wherever you've got a mountain range where you've got cool winds aloft, and as they cool down at night, and the gravity just pulls the wind down into the valleys during the early morning. So I could easily imagine it being in the Otways as well. Okay, so let's talk a little bit about some of the dynamics of air under clouds. So as we said last time, where wind, of course, in a low pressure region rises, and as it rises, it forms cloud. As the air cools, the water vapor becomes droplets and form clouds. What happens to that air is as it goes up, it eventually circulates out of that region and starts to fall back down to the in a higher pressure regions to either side of the cloud, and as higher pressure winds come down, you get gusts of wind, because you've got winds that are higher speed aloft coming down with the high pressure system, and it produces gusts at the surface. So as you go to the edge of these clouds, you'll get gusts. In the middle of the cloud, you'll get lulls. So and not only will there be changes in speed, there'll also be changes in direction. The gusts tend to be, of course, they're short in duration. We're not talking about long duration changes of wind speed, but you get these increases in speed and increases in changes in direction. So what happens? Back to the chestnut of Coriolis we talked about last time. Coriolis is we talked about it last time in terms of explaining how the wind changes as it goes across the isobaric lines. It's the thing about two important things about Coriolis to mention. First of all, well, two or three things. First of all, it's a force that is it a real force? The answer is, well, it's a force we have to use to explain how we observe things, the wind direction and movement of things, because the Earth is rotating. And two important things about Coriolis. Firstly, it is proportional to how fast the thing is. So the faster the body is moving. So if something is moving faster, the Coriolis force will be stronger. The other thing is Coriolis force always acts at right angles to the direction of motions. So it always tends to bend things. So two important things about Coriolis. The stronger, the faster the body is moving, wind or what have you, the stronger is the Coriolis force. And it always acts at right angles to the direction of motion. So it tends to change the direction. So when you've got this wind coming down aloft as a gust, because of Coriolis, it's coming down a higher wind speed. Its direction will be slightly different to what you see in the lull. So you get this change in direction from the center of the cloud, where the lulls are, to the edges of the cloud where the gusts are coming down. And so you can get both increases in wind speed and a change in direction. And of course, they can be important from a sailing perspective. Okay, let's talk about some longer duration changes in wind speed. Okay, so lulls we talked about as brief changes in wind speed and direction. Squalls are, of course, are a more serious, longer-term change in the wind speed, usually associated with something like a cold front, and they can be pretty nasty in terms of wind speed, wind direction, and precipitation. And then following on from that, we have the possibility of thunderstorms. So there you go. Thunderstorms combine a lot of the things we've talked about, the moisture in the air, the mechanisms that causes the air to rise, and whether it be cold fronts or orographic lifting or just thermal, causing the instability and the stability of the air packages as they rise. And the net effect can be quite nasty, winds and precipitation. Okay, last thing I'd like to talk a little bit about is the effect of obstructions on wind. As I said, because of Coriolis, if the wind is slowed down by some mechanism, and in this case we're going to talk about land effects of land, that will cause the direction to change, because as the wind slows down, the Coriolis force will be different, and it will cause the direction of the wind to change. And in the southern hemisphere, if the wind slows down, the wind will move to the left. It'll veer, as I've shown here in this graph. If the normal wind is in this direction, with surface friction, if air moves over land, it will slow down and it will cause the direction to change in a clockwise direction. So think about this. If you were coming up the bay here and we have a southerly wind, and you're heading up the bay off of Prince George, then what happens is the land breeze will be a little bit, because it's slowed down, the southerly breeze as it's blowing over the land will slow down, and it will have a slightly different direction, as I've shown here. And if you add the green and the blue together, you get the yellow effect, the yellow net effect of the wind. So it's both stronger and slightly different in direction as you go past the Prince George Bank. And as you go further north, when you get beyond the effect of that slower land breeze, and you really get back to the full gradient wind. So as you sail past this land mass, the combined effect of the slower breeze going over the land with the gradient wind gives you both a change in speed and direction as you go past the landmass, and as you go further north, then that effect goes away. So the effect of these sorts of things can be significant in terms of sailing strategy, in terms of wind speed and direction. Okay, any rules of thumb about how close this occurs? I don't think there's any rule of thumb, but obviously, as you're closer to the land, the effect is stronger, and further out to sea is less. But I don't think there's any rules of thumb that I can give you. Okay, last thing I'd like to talk a little bit about is the effect of wind on the sea state. And here the sea state or the wave height depends on obviously the wind strength and the distance over which the wind has been blowing, which we call the fetch. It also depends on how long the wind has been blowing. So here are some examples here of the bay, where at 10 knots, I'm not sure you can see this, the wind is blowing from the southwest, and very low wave heights down below in the southern part of the bay, and more waves up towards the north end of the bay. If the wind speed is up to 20 knots, you see the wave again. We start to see higher wave heights in the southern part of the bay and increased waves in the northern part of the bay. So because the wind has been blowing over 20-30 nautical miles, we get stronger waves up in the north end of the bay, and not much in the southern part. And then as the wind picks up, of course, we get increased waves more generally. But the so the two things are how far has the wind been, how long has the wind been blowing, how strong is it, and over how long is it, how far is over the water has been blowing. The fetch determines the actual wave heights. Here is a more extreme example. In 30 knots, you see you get the same thing. You get low waves in the southern part of the bay, increasing as we go towards the northern part of the bay, as the wind has been blowing further over the sea, over the bay, and then that the effect is even greater at 40 knots because the wind speed is much higher. So here the takeaway message is the wave heights are determined by how strong the wind is, how long it's been blowing, and how far over what distance has the wind been blowing in terms of determining the overall wave heights. Here's a good example. We know in winter the prevailing winds in winter here can often be northwesterly, and so you can be up in the north end of the bay with quite strong northwesterly winds, even a gale, and then the waves are not too bad. But down in the southern part of the bay, Mornington, it can be pretty severe. I mean, it's not unusual to hear about how the Mornington Pier and the Mornington Marina has been messed up pretty badly, and boats blown ashore because of the strong winds. Because the winds coming over from the northwest build up such a fetch, the seas are pretty wild at Mornington. So that's an extreme example of that.
I've put up the link to the wave buoy at outside the Heads Ray for those who are interested.
Yeah. Okay. Good.
And I'll just launch your poll for you.
All right.
That's launched. And I'll just copy that and put it in the chat for those who can't see it. Go to the chat, and here we'll paste that in the chat. We'll send that out to everybody. And we've got some D's and one B on the chat. I think the D's have it, Gary.
Yep.
Good. We're just going to have a look at the poll. Just keep waiting a little bit, Ray.
Yeah.
Results are still coming in. We've got quite a few D's here, which is excellent. And in the responses on the poll, we've got lots of D of, hang on, I'm not looking at the right one.
Good. No,
93%.
The D's have it. A couple had B's, no, but it's all of the wind speed, the distance over which the wind has been blowing, and of course the time the wind has been blowing. All those three things determine the effect of it. So D is the correct answer. Okay, that's all for me now. And
thanks, Ray. So we're time is currently 7:57. So we're going to have a little 10-minute break. So if you come back at 8:07, go and do what you need to do, and we'll get into some homework and some other bits. So go to the responses and give Ray a clap for his lovely talk that he gave us tonight. And we'll see you back here at 8 minutes past.
And if you have any questions in the meantime, put them in the chat.
Right, we've got a nice little 7 minutes to go. Ray, well done. That was a nice talk. I liked your bits about Antarctica. They were interesting.
It was amazing how quickly that happened. We came ashore in pretty benign conditions in the Zodiac, and within 10 minutes, this 40, 50 knot breeze was rolling down the hills. It was a bit scary. Bit scary,
any sign
actually.
of it? Any sign of it before you started, or?
Not to me, and not to anyone else, I think. But so it really caught us a bit by surprise. But it was pretty nasty.
Was there somewhere to hide out of the wind, or did you just have to crouch on the ground and get blown off the ground?
Okay, so we were in ashore at this little settlement called Grytviken, which happens to be a British research station.
Yeah.
And it's perhaps more famous because it's the burial ground of Ernest Shackleton.
Yeah.
And we were over at Shackleton's grave having a little toast of Shackleton whiskey, actually. And then all of a sudden, this wind came blowing down the hills, and we had to. We were stuck in one of the huts there in the research station for about 3 hours.
Oh, so at least you went cold.
It was raining, and wind was blowing. Yeah. And a couple of Zodiacs got wrecked, turns out. It was pretty nasty for about 3 hours.
Because that Katabatic could probably flip a Zodiac without any people, and easy enough, wouldn't it?
What was that, sorry?
It could probably tip a Zodiac upside down.
Oh, easily. It was too dangerous to go back on the mothership, so we had to sit there for 3 hours or something like that. Mm-hmm. It was pretty nasty. Yeah.
Yeah. It's interesting how those Katabatic winds, they do run out, but it can take a while.
Yeah.
We classically see it from the Unangs, and the Katabatic will come in winter time, and it'll blow 20 knots at Fawkner Beacon.
Yeah.
And there'll be a southerly blowing at the other end, and 20 knots at the wind. And interesting.
Well,
bits and pieces.
The Antarctica is an extreme place for it because it's so cold, and it's so in South Georgia. The coastal line is so mountainous. You've got these really cold.
What sort of height are the mountains, right?
Oh, probably a couple of 1,000 meters.
Oh yeah, so they're big.
And you've got these glacial valleys, so the cold wind can just blow down these valleys. It can be quite nasty. Yeah. Okay. So. Yeah.
No, frightening.
Yeah.
It's a bit like a cold front when you're doing a Sydney Hobart. It has the same kind of emphasis to it.
Yeah. No. Yeah. Well, the wind. I think we probably had 40, 50 knot winds for at least a couple of hours.
Yeah. It's one of the things I'm always trying to get information on is whenever we get a cold front in Australia, often you'll see this speckledy cloud behind the cold front, and that indicates that it's super cold because it makes ice crystals of the cloud.
Yeah, sure.
And you get that combination of very cold and then sort of very strange in some places and conditions. You can get 50, 40 knots, and then you'll get 20 knots, and then back to 50, 60 knots. It'll just go up and down.
Yeah.
Yeah.
So.
Yeah. So anyway, that's all the fun of weather.
I think it was really interesting for me to compare the glaciers in New Zealand to that in Antarctica, because Antarctica is very barren, it's very cold, very mountainous, and you're lucky to see grasses a meter high.
Yeah.
And whereas in New Zealand on the South Island West Coast, because of the orographic lifting of the wind coming in off the Tasman, it's just so wet, and the vegetation is lush. 60-meter high trees, and you're walking through rainforests all the time, and so it was really quite a contrast to the two. In fact, there are only 3 glaciers in the world that are in rainforests. 2 of them are in New Zealand, and the other is in Brazil. So it's really quite a contrast between Antarctica and South Coast, South Island, New Zealand.
Yeah, no, it's amazing how the unique features in
I mean, if you go to a place like Milford Sound, which is incredible, and which is a glacial valley formed by glacial valleys. As I say, the rainfall is 7 to 9 meters a year.
Yep. Ray, the interesting thing about Milford Sound is because of that rainfall and the rain goes into the water and creates a freshwater layer. It's
yes.
You can scuba dive in there. You can scuba dive and drop below that. And be 10 or 15 meters down and be like you're 40 meters down and seeing vegetation, well, not vegetation, but coral and things that you would normally only see at 40 or 50 meters. It's apparently absolutely amazing. I was scheduled to do it 2 weeks before COVID hit and haven't done it yet. But
as you may know, there is a coral reef that's been created in one corner of the Milford Sound. And
I didn't know that.
Yeah, there is. They've produced for the reasons you said. So I didn't actually go there.
I think it's called black coral. From memory?
I think you're right. But it's an amazing place. Milford Sound is absolutely well worth visiting.
Yeah.
I think it's a combination of the very steep sides of the mountains and this sort of tea-like inversion layer of fresh water.
Yes.
It just creates very low light conditions at about 10 meters that changes everything. Yeah.
Okay. Interesting. Yeah. Okay.
Ray.
Hello.
Yeah, Lee, just before you go on, Lee, can you just make sure you've got 2 computers there or something, but we're getting echo from you.
Yep, I had a different speaker on. I'll try turning that off.
Yeah. All right, who was questioning, Ray, the next one?
It wasn't a question, it was just a comment. I used to live in Christchurch and, you'd get hot northwesterly winds blowing in Christchurch. And at Mum's house over on the west coast, there'd be pouring down with rain.
Yeah. Well,
the wind, the amount of moisture that got sucked out of the air.
Yeah.
And then incredible. The friction of it running down the side of the hills. Yeah.
And you come over the east side of the mountains, and it's quite dry.
Yeah. Christchurch would be hot, dry, not northerlies, and.
I drove
on the other side.
I drove across from the glacial area, Franz Josef area, across to Christchurch, and it's not quite desert, but it's very dry.
Yeah.
It's so incredibly different, and on the east coast, on the west coast rather, you're in rainforests. It's incredible.
Yeah, and then you get that long cloud right up the middle of the South Island, hence the the land of the long white cloud. Yeah.
Yes, indeed. So I was surprised that, as I say, that the rainfall there is twice the Amazon rainforest.
Yeah.
Not 7 to 9 meters in a year.
I thought you were being conservative. I've heard up to 12.
Okay, well, I'm just quoting what I was told.
Yeah,
and so that's why. I was there in late autumn, I guess, and the waterfalls weren't spectacular, but I could imagine in spring and early summer when with the spring rains and the melting ice, that the waterfalls would be incredible, but the chances are you're going to get rained on as well.
All right, Ray, we might just take this opportunity for everybody to turn off their microphones till I finish my section so we don't run too late.
Yeah.
So just wanted to remind you where we were last week, and we had that little video talking about the weather that's happening. And for those of you who earlier, I was complaining that I needed to get an extra doona out. And just looking at this little map that we have up here at the moment, you can see in this area 1 here, this is the cloud band that was bringing all this moisture in towards us. In the section 2 is where that little low pressure is looking at forming, and this very clear area here and this low pressure system off the coast here that's rotating in a clockwise direction, as Ray told you, is driving very cold air from down south up into the whole of this Queensland area.
Grant, Simon, your cursor's not showing.
Is it showing now?
Yes,
Yeah.
thank you.
Okay, so we talked about this is the first area here where we're getting all that cloud mass that came in. This area here is where the low pressure is forming after that. And then this area here is that very cold area that has happened, the clear area in the coast. And then this low pressure that's rotating in this direction, putting winds up the coast. And do you know what these winds are doing to the sea? Well, yesterday there were 6 to 8 metre seas on the coast north of Eden, and they predict they'll go down to 4 to 6 metres carrying on. So those of you going up to Queensland, I hope you're all tucked in Bermagui and other places, because it'll be rolly, wet and cold. So just to show you, this is again just information that you can get from the BOM and from looking at YouTube and these things, is they just do this explanation of what's happening with the weather. And what the areas that Ray is trying to teach you is it very, very good explanations. All right, what we're going to do now is that in your homework, it's suggested that you go and look at leaving on the 14th at some sort of time. And what we're just going to look here at the broad scheme of what that weather was doing when we looked at it last week when you should have started your thing. So if you can look here, where that stage we had this broad high and we had this low down here and these 2 cold fronts that were coming towards us. If we go and have a look on the 15th at the same 10 o'clock in the morning, we can go and look, so when you're looking at the grayscale, and the good thing with the grayscale is this gives you the cloud masses, which we can see. So you can see that last slide I showed you, this mass hadn't come into play down here, and these fronts hadn't come across. So if we look then further on the 10th of June, and so this is where we're starting to go into the long range. So when I told you to look on the BOM site, and we looked under weather maps, and we can see up the top, and these are the MSL projections, and also they give us precipitation. So these green bits and these coloured bits are the winds, and there you can see that low that's kind of stuck in New Zealand that's been going on for a long time. So if we look around here, and if we look at what the winds are likely to be here, is that leaving on the day that we wanted to was not looking too good. If we kept looking as the time went on, that low pressure here is still staying here and it hasn't moved, and so it was going to be harder of wind to move off the coast. If we keep going and we look now at the 16th at 10 a.m, we can see that this high has started to move towards the coast, so it's moving this way, and it is giving that strong wind that is going up the coast this way and those cold conditions. And it's also starting to give us some easterly winds in here. We go on to the next day, which is the 17th. We can see that that low pressure still is dominating here and it's squashing everything out the back. And we can see our high isobars, so anti-clockwise cycle, is starting to give us southeasterly type winds. So going towards the prom and things is not the most wonderful thing to do at that time. If we go again on the 18th, which is today, and so we could look at that situation. We've got this broad high pressure system that's sitting over us. This low, where it was going in this direction, is now starting to move slowly eastwards. So that's going to give us this high pressure system is going to start to dominate. And so if we look at the winds as we get today and tomorrow and this weekend, it looks like we're in for a lighter trend of wind. So this sort of system that we've done here is just looking at over time what the synoptic charts are showing us and what we are expecting in little windows of gaps. So again, if we look here, and this thing here, which we looked, the high pressure system is here, but we've got this little low in this quadrant that we have to watch because this is starting to come this way now. So if we're looking for a little window to go north or go sailing somewhere, is that we might only have a 1, 2 or 3 day window between this low and the sea reducing on this coast here. If we were going up towards Queensland for the winter, we would only have, looking at this synoptic chart, you would say broadly there might be a 2 or 3 day window to escape. And if you didn't take that window, it was going to be difficult and windy and uncomfortable. Okay, and so there, this is for, so what will we be at Sunday? And so you can see this low pressure is still hanging here, and so it's still squashing us up. But the good thing with this low here is it's moved to 1,007. So it's starting to back off. So if we go back here, and we can see here it was 1,000-ish, and so it's starting to go up. So it's not going to give us as much trouble as we anticipated. All right, so what we asked you to do is to use Windy to come and put your GPX file in. We told you on the website where you could go and get that GPX file. And so what we're going to show you here is what you should have done if you didn't manage to do this successfully. So you can see the big arrow here which says go and click the window. And so when you click the window, it gave you something up the top here called distance and planning. So just for everybody is, if you do this on a computer, it'll work exactly like this. If you do it on your tablet or your phone, it'll be slightly different and a bit harder to do. So I would suggest that you all start with your laptop or your desktop and start with this Windy. You don't need a prescription to do this. This is totally free on a laptop. It's harder to find on a tablet or a phone. So you hit the distance and planning bit up here, and then that'll take you to this screen here, which says here, click on the map to adjust waypoints, or it says upload a GPX file. If we look at the next step, is that we went and we uploaded this GPX file. But one of the things that if you notice on this screen here is that if we don't do some other things, it won't give us a start time and a finish time. So the most important thing here is that we click onto a boat, because this allows for aeroplanes, cars and hikes, and for VFR for airplanes and IFR and airgram and all sorts of other things. And so if we're on a boat, we need to select that boat. And then the next thing that we need to do is, once we've selected the boat, is we need to turn on the boat speed. And when we turn on the boat speed, it will allow us to get to a start time and a finish time based on the boat speed that we have chosen. So very important to remember, we upload our GPX file, we go down the bottom and we tell the thing that it is a boat. And for those of you who are saying that, yes, there was the 21st departure, originally the online course said the 14th, so I'm just showing you that. And once you've got the trend of this, I wish all of you to go and do it again for this weekend and see if there's a better opportunity, because we are going to have a little look at what happened on the 14th and whether you'd want to go then. So the fortuitous thing for us is, I think most of us will agree at the end of this is what we should do. So that's last week I told you the next date, but there were a lot of people in the class who had done it according to the homework, and the homework says the 14th. So we're just showing you that, but after you've done this, you'll be able to do it at any time you like, as long as you understand the
So Simon, we've just got a couple of questions in the chat. David Schiller, do you want to take yourself off mute and just tell us what's confused you, please? And while that's happening, Laura Cora's, her computer's showing a screen showing the route planner is only available on a premium. And Hugh's also saying the freebie won't do the boat to be used.
Yeah, Delma, David here very quickly. Now, I understand Simon now. He's showing on 14, but yeah, people can do that, and I guess the 21st, which I was working on the last couple of days. But Hugh's right, though, because I had to play with the subscription, and if you turn it off, you can't click the boat. So you have to have a premium subscription to do the boat. You do get some of this planning at the bottom of the screen, but I think it sort of defaults at elevation. So other people may have that problem.
Did you have a look at how much it costs for the subscription, David?
Yeah, it's I think it's like $80 a year or something.
And how much was it for shorter?
It's not. It's not too onerous, but yeah, it depends on how much sailing you do. Whether if you go at the heads a bit, it's probably worth it.
But there's a shorter subscription, isn't there?
Yeah, yes, of course. You can do it by month.
Yep.
Yes. What's it by month?
I don't know. To be honest, probably 15 or something. So it just works out cheaper if you get 12 or something.
Yeah. So I would encourage everybody, if that's the case, that I thought I tried it and it worked, but maybe I was wrong. But anyway, what we really need to do is for route planning to work properly, it really pays if you have this and you can use the boat and the distance. So if you could just look for all of you, if somebody could find out how much it costs for a month. But anyway, I would encourage you to do this because this makes it really easy and it makes the route planning to get down there super easy. All right, let's carry on. You can use Predict Wind Premium, and you can also upload GPX files to Predict Wind, which if you save yourself for Thursday night, I'll show you how to do GPX files in Predict Wind, but you can do that whatever you like. But you can do this all manually. You can do the route, so you can do the route in here, but you can't just play this bottom bit. So you can still do it with Windy, uploading your GPX file. You can look at the wind on the course down the bottom as you moved along. It just doesn't help you as much as this does, because with this particular system is if I go and you look in the next slide, as you can see, I can move the window by changing the boat speed, so the window gets larger. If you look between this one and this one, you'll see that I've made the boat speed slower, so it makes the duration of the event quicker. And it's a bit confusing that this start time here and this finish time relates to this end of the scale. So it's a bit confusing on how it works, but it shows you the wind, but I'll show you with the next slide how it works. And so here's moving the boat time by moving the start time across the screen a bit and fiddling with the boat speed. So you can do all of those things by adjusting them up and down the circumstance so that you can get it. If we then go and move in this bottom component of the screen here, it will show us moving along the water. And for those of you who are working on the chat, what would it be like going on at this time when we're starting on the 14th at 9 a.m? What would this leg be like? So that's a nice easterly wind. They're probably, if we look down the bottom, we're looking at 1.5 to 2 meter waves. We're looking at 16 to 27 knots, east-southeasterly, and going in that direction would be it fails on the two rules that we needed above 20 degrees and below 20 knots. It would be quite uncomfortable bouncing, and the food that you had on board would not be consumed much because it would be very unpleasant. So if we go along and your journey there, just watch the screen, as this is what we're working through. So work with me through the screen, because some of you might have the wrong date. And so one of the things that we can go and look at when we've looked at the wind, we're looking at our journey, and now we need to look at some tide times. And we told you in the exercise to go and have a look here. And so when you went into the look here and you looked at the BOL map, and you went down here and you chose tide predictions, and then once you chose tide predictions, you will go down here and you will choose tidal streams. You need to click that, and if you see the next slide, you will see that it's got only 3 tidal stream locations in Australia, and you click on this bottom one, which is Melbourne, and your tide time stays like that. So if I was trying to leave Port Phillip Heads on Friday, can some of you tell me that I'm leaving Sandringham? What time would I leave Sandringham, and what time would I get a clear passage through the Heads on Friday? In the chat. So we're looking at going on Friday, the 4th of June, did 14th of June as a plan. And if we were trying to leave Sandringham at daylight, what's our first opportunity to go through the Heads? We had William told us there's one at 20:32. And there's also somebody else has told us there's one at 1:53. Beautiful. That's all you're getting it now. So we're looking at that little window. So what we want to have in our piece of paper for planning is, if we were going on Friday, we've got a 1:53 departure. And if we go back here and have a look, what's the distance from in this first leg here? Anybody tell me what the distance is? Your first leg distance? Okay, we're 28 miles. Lovely. We've got 28 miles. So if we're doing 7 knots, that's 4 hours. So if we allow a 4-hour window, and if you always plan to leave in for 4-hour window, I would suggest you use a 5.5 time for people to get down the boat, because some way there are some people who are always late, and if you're looking at aiming at a window, being a bit early and having to wait a bit or go a bit slower is a much easier option to go down there. And if we look back at our windy, is that getting down the bay was the easy bit, and the easterly wind would have been a nice comfortable reach, but leaving on that day was not exactly the most easiest thing to do. So if we were looking at our 2 windows that we're looking to comply, is there we have the slack water. So very important that everybody remembers is that when we're talking about Port Phillip Heads, we're interested in the slack time. And these next columns here, this column tells us the maximum, and it tells us by colour is that when it's red, it's coming in, and when it's blue, it's going out. Sorry, the other way around. Blue, it's coming in at 200, red, it's going out. So remember always is when it's outbound, it can be very dangerous in Port Phillip Heads if we've got a southerly or a southwesterly, and the tide's going out. What's going to happen to the waves if the water going outside the heads is going at 4.5 knots. And if you look through here, you can sometimes see up to 6 knots on some occasions. Yep, so some of them had 10 knots, so you could do that in 3 hours. So yes, the regional exercise did have sorts of fast speeds, but I don't know any boats that do that. So if we look here, we're looking at getting our tide times to go out the heads, a very important step that we start our journey in a comfortable fashion, because I can tell you, if you're a skipper of a boat and you take your crew out when it's very uncomfortable going through Port Phillip Heads and you roll around, everything gets thrown around and the crew gets thrown around, it's not a great start to the journey. Now, if we look at the other end, if we go back to our, did I have that? Did I forget that one? So if you go back from here, you'll go back into where you can get the list. Up here, you can go locations map, which is this one here. So up here is either locations, which is the one we looked at before, or you can go to a location list. And when you're going to somewhere like Lakes Entrance, it's easy to go and just look at this list and pick a popular space because there'll be an actual location. So we go to Lakes Entrance, we look at that particular spot, and we go and look at exactly the same thing. And can somebody put in the text messages when would be the ideal time to go into Lakes Entrance? Anybody got any ideas as when you might go into Lakes Entrance? Yeah, we've got some 3 hours after light. Definitely. So I think the most important thing is whenever you're doing this is you want to have the tide to be at least at half height, and you want the tide to be going in because most of the time the waves are coming onshore, and those onshore waves with an outgoing tide will get high, and it will be very difficult. But again, if this is a new place to you, is you would definitely want to make sure that you arrived at high tide or just a bit after, and so that you made sure that you were also in daylight, so you came into the harbour with good vision and good places to go. So for all of you, can you tell me, and I don't care which date you started, how many of you stopped at Refuge Bay? If we could have that on the chat. So Tim and Caroline, yes. No. Sharon didn't. Janet didn't. Sarah did. Igor, no. Nope. No. Yes, yes. No. Okay, so one of the things that is most important that we consider here is even if you did or didn't stop, is what would you do when you got towards the prom? So we had somebody who said I had the wrong dates and the weather was really light, so I didn't stop. Yep, that's really fine in that it didn't matter what you do. But one of the things that we want to do in our planning is as we approach the heads is we need to get on the internet and do another reassessment to decide whether to continue or not. Generally, most of the time, yes, and David, that's beautiful. Recheck the weather and make sure we don't lose that opportunity, which is to go into the harbour, because when we get 30 miles away and we might have to go back into the weather to get there, we're going to be reluctant to do that, and we're going to tend to take a risk by going into Lakes Entrance maybe at the wrong time. So who can tell me if we miss Refuge Cove and Lakes Entrance is not suitable, where's the next destination that we can hide if we don't want to go backwards? Okay, Peter G, how far is Eden from Lakes Entrance? Who can give me a dimension of Eden from Lakes Entrance to Eden? Yeah, behind Gabo Island or Point X, yeah. Anyway, it's in excess of 90-ish miles. So it's one of those things that when you're going across that bit of a paddock is at Wilson's Prom, you really, really want to decide really carefully about whether your strategy is correct or not, because if you happen to get caught in something or you happen to miss, it's 90 miles, which can be, sort of 15, 20 hours. So it can be a long, long, long time to get there. So very important that you make sure that you pick the right moment. So if we look at the next slide, is that we were just again looking at Windy. We were moving along and we were using this under the menu system, and we were going to look at waves. So we clicked on Windy and we looked down here at waves. So this little piece here, if you're not seeing it, and this is where we can choose waves. And when we choose waves, we can use this little graphic here, and down the bottom here it gives us temperature, it gives us waves, wind gusts, waves and swell period, and all sorts of fantastic things. So I'm going to show you what that looks like in magnification. So you can see here we've got a direction of swell in this way. We've got the wind direction in this direction, and we've got the swell in this direction. And if we look at the height of the swell, we've got 0.4 of a meter. We look at the height of the swell and we've got 1.9. So this can cancel each other out, but sometimes they can add together. So for our planning, we will say 1.9 plus 0.4, and we'll be looking at the 2.3 meters for our planning. But again, this Windy thing is really useful. This is, as you can see here, this is the entrance to Lakes Entrance, and it says Lakes Entrance up there. So you've got all of that stuff that you can see. Let me go and see if I can find the eraser. Is it going to get rid of it for me? Erase all ink. There we are. So you can see again, this nice little graphic that Windy can give you will give you all of the things that you need to know to make your decision based on where you are. And so if you think about this, where you are at the Wilson's Prom, is you want to go in there. I've got the maximum wave height you would set out in. It depends on if you're familiar with Lakes Entrance or not. So 2.5 meter seas for my first time into Lakes Entrance, I'd be kind of a bit reluctant to go there. I'd be looking at 1 to 1.5. So somebody asked me why you got 2 swells. So this, let me just get my pen out here and make my thickness bigger. Thickness 6 is all right. So this swell here, for most of you who might not know, that this might come from that low pressure system that's over in New Zealand, the swell comes. So the swell is related to some weather system somewhere that's bringing the swell in, and it's going there. So I can tell you, for example, in that when we went in behind Fraser Island, and we were in a boat, in the motorboat, we were in maybe 5 or 6 knots, and we had a 2 meter swell that came from New Zealand over to Fraser Island. And so that swell is what happens, and that's basically comes from some weather system somewhere. And this second swell would be coming from another section on this, from this direction as well. So we've got 2 swells from 2 different systems. And the problem with this particular thing is, if you were going in there, those 2 swells would make it very difficult to steer in a straight line. Okay, so here's a blow up of what we were talking about. So if you look in any particular line, if we look, say, here on Saturday at 10 a.m, we can see the first thing is telling us that there's some rain. The second thing it's telling us that it is 10 degrees. In this particular time, it's telling us the wind is going to be 1 knot, and it's looking like it's from the eastish, and 9 knots maximum. We have waves of 1.3 meters. We have swell of 1.3, and we have a wave period of 7.5 seconds. And we can see along here the tide highs and lows, and in this particular area here. And so, sorry, this is the highs up the top here, and down here are the lows. So really good in this particular thing, that on this one screen we can see everything that we might need to see. So that's basically what we have and what we can do to see all of the things that we need to see on Windy. The thing that important to look down the bottom here is the red thing says we're on waves and tide, and the other red says we are using the European model. And we can, if you have a fancy thing, you can turn on the 1 hour forecast here. And the other thing that is also possible is that you can compare models, but we'll go into that on Thursday. Yes, so somebody has mentioned that current is limited to 3 days, so that is correct. Current in Windy is, for some reason, it used to be more, and even in this prescription one, it's 3 days, so it's something that you have to look up late in the piece. The reason that I'm showing you this particular area here is this is showing some quite big swells. And if you look up the top up here, you can see this is forecasting in this pink bit 2.6 to 3 meters type of swell in this particular location. All right, now I'm just going to play you, this is Predict Wind, and I told it to go on the Saturday, and then I told it to go a day apart. And excuse, there's a little bit of pixelation and jerkiness towards the end, because for some reason my Camtasia is not working as it used to. But I will just play this for you. And here we're using departure planning in Predict Wind, and it's looking at the models as it starts. This one started on Friday, as you can see, and you can see we're in easterly, and it'll be a hard week and a bumpy ride to get to Refuge Cove. After that, it gets a bit better, and so then we see this one leaves on Saturday, and this one starts to get better, starts in a bit of easterly, and you could do this one and park in Refuge for a bit. But you still look at the other ones. There's a bit more hard southerly comes through there for leaving on Saturday, Sunday in the early morning. And so it tends to be this kind of scenario here, a little bit more wind, and there's still that big bit of red wind going past. So the last one leaves on Monday, and you can see the Monday one, it gets along to the prom pretty easily. And
Simon,
the wind does
we've got
pick
an
up a
echo.
little bit there, but you could pop into Refuge for a few hours because, as you see, as we go along, the wind moderates. So I would recommend that my preferred time would probably be leaving late Sunday or Monday. Is the echo gone, Delma?
When the video stopped, I think you've got to turn your sound off. When
Yeah, we're using departure planning and Predict Wind, and it's looking at the models as it starts. This one started on Friday, as you can see, and you
Okay.
haven't undone myself. Yeah, so you saw that model there where you went along on Predict Wind and you saw what happened to the various models. And again, I want to emphasize with you and with people is when you are cruising, you need to give yourself opportunity. And especially if you were starting on a trip, you wouldn't want to start in any nasty weather. Okay, so I did have a message here. Slack water into Lakes entrance, but if you're going in there for the first time, you would want to be slack water high. You would want to have a bit of depth under your keel, depending on how deep you were. If you were a power boat and you were only a metre, you wouldn't worry so much. But if you were a keel boat with, 1.8 or 2.2 or something like that, you'd want to do. Okay, the next step we're going to talk about is navigation planning and thinking about safe harbours. And the questions of safe harbours that we want to ask ourselves is how easy it is to enter, what winds is it safe for, is the tide a factor, is the sea state a factor, and the final thing that when we think about this is, are we realistic about our departure time? So it's something that we need to consider when we're doing this, and I'm just going to give you a little scenario of what happened to us one day. So this was unfortunately 49 years ago. We were coming back from the Melbourne to Hobart, and we decided to go up the east coast, and we'd had a lovely time here in Wineglass Bay, and this was on Yoko, and so we kind of thought we knew what we're doing, and we decided to leave Wineglass Bay at midnight, and as we departed from there, we went up here, and where it is number 2. I think I've got a magnification. No, I haven't. So at number 2, by the time we got to number 2, we had 3 reefs and we had the storm jib on. We had very strong westerly winds. They were up to 35 to 45 knots, and we decided to continue. What was wrong with our strategy?
You're crazy.
Okay, in the text, what was wrong with
You
our
don't
strategy?
have anywhere there's nowhere safe to go after for a long while after Wineglass, and it's only going to probably build once you get up the top.
Yep. So anyway, we were going along merrily, thinking that we were racing sailors, and by the time we got to turning into Bank Strait, it was blowing 70 knots. There were 14-metre seas, and we put a young fellow on the wheel, and we went over a wave, and the wheel spun him around. And so eventually I went on it, and I've never experienced a situation where you go vertically up the wave and it feels like the boat was going to come over your head. I do have a very strong recollection of while sailing and looking down the front hatch to see the skipper's wife coming from her cabin on the port side and crashing into the chart table at high speed, and that's where we ended up. So if we're looking here at our strategy, is that we were kind of stuck. But if you really think about it, with a strong westerly wind, the notion of continuing up this way was probably a poor strategy, and coming back this way might have been a better strategy. And so part and parcel of what I'm trying to encourage you to do is to think about where you would go in this particular location. And I draw your attention to this little thing here that exists on Navionics. And that is showing you at this particular time when I did the snip, is there's 2 knots of tide going this way. So this would make the sea flatter, but again, as you know, with tide, it'll always go this way. So if you imagine waves dancing down this way and the tide against us, it would make those 14-metre waves no longer with a nice round shape, but with a very uncomfortable shape. And so this kind of strategy decisions that when you do these things is you need to think about. If we had happened, let me just clear some of this mess that I've made here. Come on, clear, erase all ink. If we had thought about getting closer to the coast and snuck along, let me just put my pen on, and if we'd snuck along here, is up here at Shore Island is quite a nice place to hide out in Banks Strait. So probably in those winds, it was probably not protected enough. But one of the things that I can tell you for your little bit of wind. So Carolyn's asking, Tim and Caroline, what winds you're expecting? We were in the days, we're talking 49 years ago. There was no internet and there was a bit of weather on the radio, but the weather on the radio said it was going to be fine. And we struck this 49 winds, and I can tell you I did remember the skipper Robin getting on the radio, and he said in a very loud voice, "You weather forecasters should be boiled in oil." So you can gather that he wasn't particularly happy. But again, thinking about the strategy, and we'll just go and have a look at Shore Island. And so Shore Island is something that you should have investigated before we made that journey. And we should have looked at not Shore Island, it's Swan Island. And if you look at Swan Island, and if you think about strong westerly winds in this location, is coming over into this side of the island or this side of the island, are both quite comfortable places to wait. So one of the things, while it wasn't relevant in that big storm that we had, I would say to you that this particular place that is a very good place if you're coming to look to transit through Banks Strait. You can sneak up along the shore, as I showed you back here, as you sneak along the shore towards the island, and then you can hide here and wait, and you can wait here for the weather to change because you're expecting a change. You wait a few hours there. As soon as the wind comes behind you, off you trot. It's a very good way of going. So anyway, on to the continuation of our journey. Well, this is a little bit about a thing that I am very much in favour of. You used to go to Google and search these things, or go to the Ports and Harbours book. But if you go to ChatGPT, those who you don't know, is that if you look at this about Shore Island, it says, shelter, the island can provide shelter from prevailing winds, particularly from the west. However, the level of protection may vary, depend on weather conditions. The thing that is quite exposed, and so you really want to, it talks about the anchor depth and holding ground on Swan Island is not ideal, and it's essential to have good anchoring equipment and be cautious about seabed conditions. So realistically, if you were traveling around here, part of our little research would be is we want to look at what ChatGPT or Google or something says about this. Or we might go to an old salt in our club and say, okay, have you ever been to this island to have a look? Have you ever parked there? And that's another ways that when you're doing your research about where you're going, is where you would go. So it goes on a bit about here. And then we're looking at about what are our safe options on the way to Lakes Entrance, given that little talk that I gave you. And I should actually tell you in that when we got in here, we came out and we went around the top of Flinders Island, and we were in here about 4 o'clock in the morning, and the only people who could steer was Robin and I, and we spent the next 12 hours in the cockpit steering and going till we got to the top of Flinders Island and in behind the land in 12 hours time. And I can tell you it was a very dangerous situation because of poor planning. So let's just go and get rid of these things. Okay, so what are our options for safe harbours on our way to Lakes Entrance? So what's the first one for everybody? These. It's not going. So anyway, the first one that I want you to think about, I don't know why my eraser's not working. Let me try that one. No. So anyway, the first one we want to think about is Flinders. And so as we were going along, if we got caught out through here, no, my pen's still, maybe that's it. Let's go back to the cursor. There we go. So if we think about this, and when we're coming along the coast, Flinders is a nice place to go into. And Flinders and Western Port should always be remembered for boats and yachts coming back from all sorts of places. The tide might not be right getting into Port Phillip Bay, and you might be in compromised yachting positions where you've got sea and hard weather. And so going in round the corner into Western Port and then just popping in behind into Flinders is a really nice place in strong winds, strong westerly, southwesterly winds. It's a really good place to go and hide. If we look at our next place to go you remember in that slide, there were strong easterlies. And so when you've got strong easterlies, you don't want to be over here at Refuge Cove because it is quite unpleasant there. So that's Refuge over there. And so this is Oberon Bay. I have parked in there in strong easterlies. It is very nice in there. And in the corner here is Tidal River. So if you have a dinghy, you can go to the general store. But we anchored there for a couple of days while we waited for the easterly to go away before we continued on this way off to Eden. So good place to stop there. And then again, if we look at Refuge Cove, we can see Refuge Cove is quite tricky. When you go into Refuge Cove, you need to be careful of these rocks on the corner here. So you come down around, down around here and then into the harbour. And if you can, this is the prime spot.
Simon, just as an addendum, if you go into Refuge, you should be really looking at what weather's coming because it can be so shitty to get out of there if the weather turns nasty.
Yep. So again, if you think about when we were doing this, we came back here, here, and we had Flinders. So when we get to the heads from Sandringham, we're going to have another look at the weather. When we get past where Ray lives at Cape Shank sometimes, we're going to have another look at the weather and we're going to make sure our choices are the right choices. And then I often, if you haven't had the experience, is that coming into the prom and coming inside this passage here is a very much nicer way to go because you often get protection from this island here and you get some nice comfortable in the islands and around the corner here. And you can then assess, there's internet available here, so you can assess when you need to go into Oberon Bay, or you might go to Refuge Cove around there. Okay, so that's what we got there. And then if we go again, look at Refuge Cove, and we talked about staying in those places. And the other thing that we need to think about is that if we were going to park there, we need to do some research again. And if you want to do ChatGPT, it says Refuge Cove offers good protection from most winds, particularly from the west and north sector. It's relatively sheltered from the southeast, but can be exposed from winds from the south and east sectors. Holding around the cove has a sandy bottom which provides good holding ground for anchors. It's important to ensure your anchor is well set. The depth range varies, but there's ample room to anchor in depth suitable for most recreational vessels. Crowding during peak times, such as holiday periods, weekends, the cove can be overcrowded. Early arrival can help secure a good anchorage. And it says, always check the weather forecast before anchoring. Sudden weather changes can affect the safety of the anchorage. And then the step 6, we'll just read you. Approach Refuge Cove with caution as there are some rocks, shallow areas near the entrance. So for those of you who haven't tried ChatGPT, it's really clever. You can go and do the same thing in Google, but you probably look at 10 or 15 sites before you'll get that information. So for those of you who haven't tried it, it's a product made by AI. That ChatGPT that I've sold you there is for free, and it is very useful. And if you saw me put an answer there for the roll card in Greece, that came from the same place, ChatGTP. It's very good. And David Schiller's come. That's very good for weather questions. So just as I showed you, that cloud before the Meltemi in Greece, that answer came from ChatGPT. And if you're a grumpy old bloke like I am, if you write emails and you're a bit short, you can just go and put your emails in ChatGPT and say, please make it friendly and nice, and it does a good job. So again, with navigation, it is very good. It is, it's again, though, all of these things that you do research with, you need to concentrate and make sure that when you do this journey from A to B, is that you do that. And so one of the challenges for you is also to go to Lakes Entrance and type in ChatGPT and say, what does it say about going in there and how would you do it? No, and that, Laura, yes, you're right. It doesn't give you real data, but it gives you information that you need to know to go into a place. Okay. Here we are at 9:01. And Ray and I have been very good with the timing. So what I've got for you is some homework for Thursday. So for your night 2 homework, if you go to the web page that we go to for all of your personal information, we go off to that web page and we can see night 2 homework. And you can see here the 2024, the weather course homework. If you click on that, that'll open a PDF and it'll tell you what I would like you to do. But down here is the winter series, race 1, 2, 3, 4, and 5 for the race on Saturday. And then there's the Blairgowrie race, the Blairgowrie return, the Geelong race, and the Geelong return race. What I want all of you to do by next week is you've been asked by me to be my assistant race director, and I've asked you to go and look at the sailing instructions and find out what the cut-off time is for the race on Saturday. And then I've asked you to go and look at the boats and find the slowest boat. And what we want to do is we want to go and look at all those courses using Windy, and we need to decide which course you're going to recommend that we sail on Saturday. Is that clear to everybody? And then the second part of the homework that we want you to do is that you're going to sail next Wednesday. At 10 a.m. you're starting the Blairgowrie race. And I want you to have a look at the Blairgowrie race in your boat, or choose a boat if you haven't got one. And I want you to look how long it's going to take you to get to Blairgowrie. And then also as you get towards Blairgowrie, what's the tide going to do to you? Right, so
So we should just double check, is everyone clear with their homework?
yes. So again, I'll just stop sharing this, and can I do that here? No, I'm in the wrong thing. So I'll just go and show you where it is. Down here is the second session for today. This is the student notes here. So if you click on that, it opens this thing here, and you can see this is where we started today. And this is the slides that we used. And if we go back to here, we can go down the bottom here and you will see homework up here. This was the night 1 homework. This is night 2 homework. And this opens the little page here and it asks you what to do on this document. And then if we go back to our page, if we click on one of these things, you'll see it'll download this GPX file here. And so there's 5 courses for Saturday's race. And then for next Wednesday's race, there's the Blairgowrie race. And then those of you who want to be efficient, you can do the return race on the Thursday. And then you can choose a date where you're going to have the best weather to go to Geelong. And for those of you who are very keen, you can see up the top here we have contact Ray or Simon, and you can send us your homework and what you are doing, and Ray and I will mark your homework and give you some feedback. Okay, all that's left to say to you is we will be back here on Thursday. On Thursday, we will be doing more details of some weather observations and some weather bits from Ray, and then I will be doing a big section on predict wind, and I will also be doing a big section on exactly what I do when I'm doing weather analysis for a race or for an event or whatever. So I'll show you exactly what I do. And for those of you who've seen me do weather talks, that's what I start. And I start looking at that weather 12 to 14 days out, and I'll show you exactly what I do. But anyway, Ray and I will be here for another few minutes for any questions. Other than that, would you put your hands together and your likes, reactions for Delma, Ray and Simon? And we will be around for the next few minutes.
Can I ask a question?
Sure, go.
You were talking about swell heights, but I guess the other big impact is the period. Is there some rules of thumb on periods? I mean, it's one thing to have a 5 metre swell height, but if it's a long period, it's pretty comfortable. If it's a short period, it's really nasty. So I'm just wondering if you've got some rules of thumb on that.
So basically, I'm just going to show you, and this will give you all the Port of Melbourne wave buoy. And so if we go to this wind and waves and wind, and I did put it up earlier, and if we go down to this Port Nepean wave buoy here, is this thing gives us really good data for you starting to understand. I can tell you a rule of thumb, but what I would like you to do is to look at this. But I can tell you that the Weather Bureau and the Water Police in Melbourne get really excited if the wind is over, the waves are over 7 metres.
Sure.
They won't let us race at all in 7 metres. And generally, if I am going in a delivery, I do not accept anything under 3. If I'm a race director, I'm really unhappy with anything over 5. And if it's over 5, I would look at a delay.
But you're talking about racing in the bay there where the waves are fairly steep. It's a bit like in Adelaide here where I am in the Gulf, where you get nasty steep kind of waves over about 2.5 metres, particularly down the bottom.
So
you're out off Port Lincoln with southern swells. I've been out there in 5 metre swells, but you wouldn't hardly know it. That's why I was thinking about periods.
So the periods is to do with the length of the wave. And so, one of the beauties is that, I can tell you we did a race from Darwin to Bali, and the period was probably 3 minutes or something. And so there were these nice 10 or 12 metre waves, but they were 300 or 400 metres apart.
Exactly. Yeah. So that's what I was just wondering about the relationship between the size of the wave and the period.
So generally the period, if it's longer, it's going to allow you for the waves to be well spaced, and that basically the longer the period, the flatter the wave will be in profile.
Exactly. So that's
whereas if they're together, they will start to rise up.
So that's why if you've got a period of, I don't know, 15 seconds and it's 2 metres as opposed to 5 seconds and it's 2 metres. I'm just wondering about the relationship and whether there is some.
I think I might give a bit of a chat about that in the next session.
Yeah, that'd be useful.
Okay,
Yeah.
I'll put something together on the causes and of the different wave patterns.
We were going from Adelaide to Port Fairy over Christmas, and there were 5 metre waves out there, but they were actually really comfortable.
Sure.
I wouldn't want to be in a 5 metre wave in the Gulf here in Adelaide under almost any circumstances.
Well, one of the classic things is that for us to go and do Port Lincoln, a race that we love, is the place called Backstairs Passage.
Yeah,
And I don't
it's
think you need to think about it too hard to know what happens there. There's stairs there. And so it's again something that you need to think about in terms of if you are thinking about weather planning, is when it says Backstairs Passage or Cape Grim, do some research because there's some clues there for you.
We had the shittiest trip to Port Fairy, both there and back, with wind on the nose both ways. But we had the easiest trip through Backstairs Passage you could imagine on both directions. I don't know how we scored that, but that was the case. It was hilarious. But yeah, that can be an extremely nasty place. Yeah.
Yes, but you know, the really interesting thing is there's a fellow called BA who sails on a boat called Bacardi, but he spends all of his life delivering boats. And if I said to BA, we're coming back from Port Lincoln, we wanted to make in a hurry, he said, well, on Kangaroo Island, you just go here, you can pull up at the jetty, go to the pub for a few days. And we went in there and it was a beautiful place to hide and the rest of us wouldn't know about it. So when you do journeys and things, it's just really, 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 when you're new at a place, you really want to go and find some people with some local knowledge and where you might go, because it just makes such a difference to your weather planning. And having these plans that I've showed you today about bolt holes, places to hide, things to do, strategies to employ will just make your sailing so much nicer.
I loved your ChatGPT stuff. You know, I was looking at the area around Refuge Coast just on avionics as you were talking, and there were a couple of other spots. And I thought you could just whack that in and find out really, really quickly whether those things were, you know, options or not. And Kangaroo Island is a classic example where there's lots of little lovely places to go, but you kind of got to hunt them out a bit. So yeah, well-made points. BA keeps coming over and winning everything on AMS except for this year. So
yes, he does that a bit. But again,
Bacardi's a weapon on AMS, particularly if it's windy. This year was a very light series, so it didn't do quite so well. But yeah, interesting.
All right, so
thanks, guys, appreciate it. Yeah.
The best thing that I can say to all of you is, please, 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 this course is about getting to know it yourself, and you won't get it unless you do homework and you